Okay, so here's our final product, our power supply, and I took a little plastic case and mounted it over top of my other power supplies and made them look really nice. I taped them together with some electrical tape, and here's I have this switch hooked up to a capacitor that changes the frequency range. You can change the frequency range based on how big of a capacitor you have in there, in the phase lock loop. And here is the resistor that connects to the phase lock loop that generates the frequencies. And let's see, I got it plugged in. We'll just flip her on here. Okay. Look at that. So it's a variable power supply. I can change the frequency. And I can change the amplitude. Make it really loud and annoying. I don't want to blow the speaker out. I'm not going to flip the range because the other range, let me turn this off. The other range goes up very high to drive Tesla coils. And so whether you want to drive high power speakers or coils or ignition coils like what we have over on this guy over here, the nice high voltage ignition coils, you could probably drive one of those with our little driver here, or Tesla coils, or what other experiments you want. And you want a variable voltage and variable frequency at high power, and this generator might be the generator for you. Let's look at that. It's beautiful, huh? Anyway, okay, so today I'm going to talk about making my variable power frequency generator. Now, I've talked a little bit about this is a phase lock loop oscillator, and this is a transistor for a power amplifier. And basically I have a signal generator here, a phase lock loop, and I put a variable voltage on the voltage controlled oscillator, voltage controlled frequency generator, and it generates a frequency and it feeds it into a FET here, field effect transistor, and then that amplifies the signal, switches it on and off, and puts a lot of power through. I can put any load I want on it, but right now I have it hooked up to a speaker. And you need to have like an inductive load. You can't charge a capacitor because there's no way to discharge it with a single FET. But this is a simple power supply for doing all sorts of neat stuff, maybe driving Tesla coils or other things, magnetic field generators, frequency generators. And right now I'm powering it off of my breadboard up here. Let's turn this thing on. Okay, so you actually need two separate power supplies because if you want to make it variable, I want to make it variable. Right now I'm using the same voltage to drive the FET as I'm using to make the frequency. But if you want to be able to vary the power of the FET, you can't really be putting a variable voltage on the frequency, because after a certain point it's not going to generate a proper square wave out of it. It's going to just not work. And if you put too high a power in it, you're going to burn it out. But the FETs are designed to take a much higher power. So I'm going to use two separate power supplies. I did a little review on this variable power supply in one of my videos, and I'm going to hack that up a little bit. And it has a nice voltage output on it, so I'll be able to marry it with my circuit and make it portable. But also, I want to get voltage from the same plug, so I'll probably run another set of wires up from this weird plug adapter that I got from this Chinese supply. And I have a second 12-volt power supply to power the signal generator. And we'll check that one out, make sure that one's working, and then we'll try to put those two together and make a portable power supply that can generate different frequencies for driving Tesla coils or magnetic field coils or various other things, speakers. Okay, so here's our wall wart power supply, and here's the end of it. We've got it hooked up to a voltmeter, and I have it plugged in right now, I believe. Oh, and there we go. 12.2 to 8 volts. So it's putting out power, so that should be good for our signal generator. So let's get these things hooked up. Okay, so here we have our variable power supply and our 12 volt fixed power supply. And this was the adapter that they sent. And I just unplugged it, and I wanted to, I cut some, where did it go now? Okay, I just cut some 2 wired cord to about the same length as this power supply is from the plug, so that I could kind of tape these both together, stick them together, something, maybe glue them together, so that they could be a single power supply plugged into a single plug that would provide both 12 volts and a variable power as well, variable voltage. And so I was trying to figure out the best way to do that, and I looked at this little adapter here that adapts from European to American plugs. They had some screws here, so I undid that. And I'm thinking, oh, this thing's coming apart. I'm thinking that, let's put this together so we don't lose that. Maybe I can solder some wires onto these parts and run the other cord, this cord here, out through the ground part, so it doesn't interfere with the plug. Let's try doing that. Maybe there's a little metal thing. This actually fell out earlier, so if I take this thing out, since it's not even being used anyway, I'll give you a little bit more room, and maybe I can run the wires in here and solder a wire on to these metal things here, maybe. Well, let me see if I can do that. I guess these things still have to make contact with, maybe I just screw them down. That may not be too good of a contact. I think I might just try to solder these things on there. And then this part will hold these contacts down against that, and I'll be able to get electricity to both power supplies that way. Let's give that a try. Okay, so these little metal things look like they kind of come out of there. I think I'd like to try to maybe loop these copper things. You don't want these to touch together, so you're going to have to wrap them with electrical tape, or I'm going to have to wrap them with electrical tape when I get done. But I think I can probably thread it through this metal thing and wrap it around and solder it real good. And that should make a very good solder contact. May have to cut some of these strands of wire off because it may be too thick to fit through very well. But let's try that. Try peeling some of these back. Remember, you're going to have 110 volts on these at very high current, and you don't want these two to short together because you will have a fire in your outlet if you do, and that would not be good. I'm going to cut all these off. That's good enough to feed this through, and I'll try to stick it through the hole here. Maybe loop it around and solder it, and hopefully this will work. If it doesn't, it's going to make a big mess out of the whole plug. Okay. So, oh man. Okay, there we go. So I looped it through and around. Then you can solder it to itself, and that should make it nice and strong. We'll do that to both of these contacts. I'll pull the other one out and try to loop it through, and I'll try to get those soldered, and we'll see if we assemble it and see if it'll make contact with both the wires and the other contacts that are required for the other power supply. Okay. Okay, so I got them both kind of wrapped around there. I haven't soldered them yet. I just wanted to test to make sure that those fit in there and that we can still plug our other plug in and it still makes contact. And it seems like it does. Okay, seems like it's making contact. So maybe I'll just go ahead and solder these in place there, and maybe we'll be, no, maybe that side's not making contact. Okay, I guess it is. Okay. Okay, if we solder those in place, maybe we'll be set to move on. Okay, so here we go again. Got our solder, and come on, got our soldering iron here, over here. And I guess let's try heating this up. Maybe I should pull it out of the plastic before I heat it up, because I don't want it to melt the plastic. I'm afraid if I don't have it in the right position, it may not fit back in there right. You know what? I think I'm just going to pull it out of the plastic to solder it. Okay. Okay, so there we have our contacts pulled out of the plastic. And usually you got to get the whole thing that you're trying to solder really hot so that the solder flows through all of it. If you don't do that, it'll kind of ball up on the surface and not make a good solder joint, and that's not good at all. Okay. Ouch. Okay, I soldered these things, and I think they're on there pretty good. So I'll try to slide the wires down and fit these things back into place, these metal clippy things. The things that grab onto the high voltage, and it's weird. Okay, well, I guess I have them both facing the same way. Maybe this is supposed to go this way. Well, anyway, looks like it's too late. I'll stick them both in there. I think one of them's twisted the wrong way. And, oh gosh. Let's make sure this thing still plugs in here. I think it does. That side plugs in and that side plugs in. And this thing may not fit down so well anymore. Let's see if we can figure out what to do about that. Those wires are pretty thick. They may be too thick. Maybe I can crush it down a little bit, stick the screws in. Let's see what we can do about that. Okay, I guess if I had to do it over again and had some other wires, I'd probably use thinner wires because I really don't need a lot of power through this thing. I tried to cut these insulation off on the top so that it would not be so high and get it flat as possible. It's still kind of sticking up a little bit when I fit it together, but maybe I can just screw it. Oh, looks like one of the contacts came out. Maybe I can get it together here and just screw it down and then tape over the crack, and we'll test the electrical continuity and see how that looks. And if it looks like it's going to work, we'll just kick the tires and light the fires, right? I mean, I'm the only one that's going to be using this, so I guess unplug it when it's not in use, because don't need any fires, right? Okay, so let's try screwing that down and see how this fits together. Okay, so whenever you're, soldering some things together, some important electrical connections, I always like to check. Okay, so we got this on ohms, and when you touch the leads together, it goes down to 0, and actually some people like to listen to the little beep. Some of these, let's see, where's the beep setting? I don't know. Anyway, some of these will have a beep setting, so if you touch it together, it will start beeping. Maybe this one doesn't have it. Okay, so I was wondering about this connection here. I soldered this thing together, or I screwed it together, and it's just making frictional contact here, and I'm hoping that's going to be good enough. If not, I may have to open it back up and solder these together. So anyway, just want to check this. So make sure that it's not making contact on one side and is making contact on the other, because if it's making contact on both sides, when you plug that in, there's going to be an electrical explosion, and you're not going to like that. Okay, no contact there, contact there. Okay, let me hold it a little bit better. You got to be a little bit careful, because if you hold, some people will hold the leads like this and you touch it, and you'll be measuring your body's resistance. You'll still get a sometimes you'll get a reading if you hold it with both hands like that. So you want to not touch the probe when you're measuring the impedance or the ohmage of your circuit. Okay, so it looks like we're making good contact, and time to move on to the next step. Okay, so the next step is that we want to connect these wires that we connected to this plug up to our 12-volt power supply. And it looks like there's some convenient holes. I like it when you can, loop the copper through and solder it back on itself, because experience has taught me that this makes a very strong solder joint, whereas if you try to just solder it to something without going through a hole and looping it around, it's much weaker and can break off. So let's try to get these things through the holes here. Make sure again that they don't touch each other, because you will be sorry when you plug it in if if there's one little strand of wire going across the two, it will be very unpleasant. Put a lot of current through that. Okay, let me have to twist this up a little bit to get it through. If you don't get all the strands through, you can always cut them off or loop them around the other side, and just make sure that they don't touch the contact, the opposite voltage. So that will be a big problem. Okay, so see, I looped both of these around. Then get all these stray things out of the way, either cut them off or solder them in place. So it's twisted around through those holes there, and we'll just get the soldering iron out, and we'll solder those things in place. Let's take a look down here. And of course, the best way to do that always is you want to. Okay, here's our soldering iron, and you got to get the thing that you're soldering the copper to very hot as well. So see, I touch both these guys, and it may take a while. Heat this thing up, and if you're soldering it back on itself, it will get a good solder joint there also, because the copper is definitely going to get hot. This question as to whether the other thing you're soldering it to will get hot enough or not, but you can tell if it flows, if the solder flows well, that it'll make a good contact. Okay, and there we go. This is looking pretty good. And we'll get the other side while we're at it. Okay, and that's a little bit more solder, and that'll be looking pretty good too. Okay. There, see, it's soldered both those wires on there. Okay. Okay, one thing you're going to probably want to do is tape these with electrical tape. This is electrical tape, because those are going to be at 110 volts, and if you put your fingers across that when the voltage is applied to the plug, you are not going to like that very much. You're going to get one heck of a shock. Okay, oh, come on. So I have some extra wide electrical tape, and electrical tape's always stronger if you go around like this. Okay, so we'll go around the prongs a couple times, to make sure that they are safe. And some people rip it. I have a razor knife here, razor blade. Okay, so there we go. It's all taped up, and hopefully you don't shock yourself on that. Okay, here's the moment of truth. We will plug our... I gotta plug it into a power strip so I don't have to have my fingers near it when I turn the power onto it. And first step is we'll flip the switch. No sparks, no boom. And let's see, we got our voltmeter here, and remember to change it from ohms to volts DC. Volts DC, look at this. Volts DC, see that? Okay, and I'm going to take one probe, put it on there, another one on there, the center, and just make sure we're getting, you guessed it, 12, a little bit over 12 volts. Okay, so it looks like we're getting power out of our power supply. So all of our solder joints are good. So move on to the next step. Okay, we'd like to marry these two power supplies together from the plug. And so let me plug this guy in. Okay. Actually, I should probably test him first, but what I want to do is I'm going to tape these together. Before I do that, let me just test this to make sure that it's getting power to the other power supply as well when I plug it in. Okay. Okay, again we have our multi-plug thing that we're building here, and here's our variable power supply. And we turn it on, it looks like the lights light up, and it's at the lowest voltage setting. So it looks like we're getting power to that, so we'll try to just tape the wires together so it'll be convenient to plug it in and use it without wires flying all over the place. Okay, so here's our plug, and we have our handy dandy electrical tape. Sometimes it's a little bit tricky to find the end. Just, oh gosh, cut off some pieces here, and we'll start at one end, probably the plug end, and we'll just start working our way down. We'll just take these wires and tape them together, kind of wrap around the whole thing. Probably should have made that longer. And just put another piece down here. Come on. There, we'll make it longer this time. Don't really want it to come apart. I like to build low maintenance devices as much as possible. And I like to make them cheap too, though, so those are usually conflicting criteria. Okay, so there, and we'll just keep on working our way down the cord until we get to the two power supplies and get them, here we go, get them married together. Okay. Okay, here we go. The cords are all taped together now, and maybe I'll tape these power supplies together so they're not dangling around. Okay, so let's just wrap this around a couple times. I'll try to get them even up here, so hopefully it doesn't waste so much space if I put it in a box or something. There, it's looking pretty nice. I always like projects that are wrapped up in electrical tape because it makes them look authentic. Do-it-yourselfer, right? Anyway. Okay. There we go. And so we have two wires coming out of here. One will be our variable power wire, and I might cut the ends off of these and just hook them in permanent. And the other one will be 12 volts. And I guess the next step is to hook it up to our circuit, which is over here. There's our circuit. It's presently hooked to our Heathkit. Is that a Heathkit? Whatever it is. Yeah, it's a Heathkit breadboard, the power supply. Okay, so move on to the next step. Okay, here's our composite power supply with the variable portion and the fixed portion. And here's the fixed DC 12 point something or other volts. And I would like to hook it to my circuit, which is over here. And one way to do it would be to get a mating connector for this and plug it in and hope it doesn't come unplugged, whatever. Another way to do it is to just chop it off, right? And I like to use razor blades. Be careful. You're never supposed to cut toward yourself, but do as I say, not as I do, right? Strip the wires back. Sometimes you can just grab them with your fingernails and strip them back. Then circumcise them, right? Strip the insulation off. And before we hook it up, we're going to want to test it with the voltmeter. Figure out which side's plus and which side's minus, because you will probably blow out your circuit if you hook it up backwards. You do not want to hook it up backwards, I'm pretty sure. Sometimes it might say on here, this long dashed line might mean it's negative, but I'm gonna check it first. I'm gonna plug it in and check it. Be careful, don't cut yourself. If you use razor blades, don't cut yourself. Okay. There we go. And let me get my handy dandy voltmeter out and we'll check the polarity of that. We've got to plug it in too. Okay, so we have our power supply plugged in, and turn the power strip on. And I was guessing that this long dashed one was negative and the other one was positive, and it looks like when I hook it up that way it is minus 12 volts, so that is incorrect. This dashed one here looks like it is the positive one, so we want to hook up positive to the right place. Okay, so let's try hooking that up to our circuit and see what happens. Okay, so we have our power supply plugged in, and turn the power strip on. And I was guessing that this long dashed one was negative and the other one was positive, and it looks like when I hook it up that way it is minus 12 volts, so that is incorrect. This dashed one here looks like it is the positive one, so we want to hook up positive to the right place. Okay, so let's try hooking that up to our circuit and see what happens. Okay, here's our circuit with the oscillator and power amplifier hooked up to it, and this should be on tighter. I'm going to have to screw that heatsink down a little bit tighter. Okay, and right now I also, through this clip lead here, I have hooked up the variable power supplies, drawing power off of the power the fixed power supply that powers this oscillator. Okay, so what I'm going to do is I'm just going to test our circuit with our new power supply. I just ran the clip leads over here, and remember we tested the polarity of these, so this dashed line was the positive, so we'll try hooking this up, and this undashed line was a negative. No. That doesn't seem to be working so well. Let me see what's going on here. Okay, so I had to make some modifications. I actually put a different transformer in for the 12 volt power supply. This is actually 11 point something, and on the plate it says it's 9. I wanted to bring it down in voltage quite a bit because I looked up the spec sheet. It's been a while since I designed this stuff, and the spec sheet for the oscillator, the voltage controlled oscillator on our circuit, says it requires a 5 volt input, 7 max, and so I was putting 12 volts in, and that other power supply was about 12.3, and I guess it was just high enough to blow this chip. Sometimes these things are overrated a little bit, so that you can run them at a slightly higher voltage, but it was not tolerating that. And so I was going to try to bring it down to 7, but this power supply is not operating at the voltage range that it claims it is. Okay, so here's our wires here, and let's just hook this. Well, excuse me. The one with the stripe is the negative, and oh, come on. Here, we'll hook it up. Okay, so it looks like it's working, but I suspect these voltage control oscillators are very sensitive to voltage fluctuation, so this probably got a lot of ripple, probably 60 hertz ripple in it. So I may have to put some regulators or maybe some big caps or something in there to try to calm that down a little bit, because that's kind of unacceptable. Okay. Anyway, so it looks like we're making progress. We've got our power supply here all taped up. We've got a variable part and a DC part, or constant part. And so we'll try to flatten the output of this one out a little bit more. Then we'll hook it up to our circuit, and then we'll hook up the variable part too, and then we should be able to have a high power variable frequency generator. Okay. Okay, so I figured I'd regulate the voltage down a little bit, because the spec sheet said it should be 7 volts max, and I couldn't find a regulator around here, but I did find a Zener diode that was 6.6 volts and about a 100 ohm resistor, and so the voltage across this should be, well, if you can see, 6.7 volts, okay? And the resistor will suck up the rest. Basically, the Zener diode clamps when you run it reverse bias or forward bias, whatever you want to think about it, the way it's supposed to be run, it will break down at a certain voltage, and it will maintain that voltage. It's a very nonlinear resistor, but you can't have, it would just draw lots and lots of current if you didn't have something to limit this once you go above 6.7 volts. So you need a resistor to suck up the extra voltage, basically. Okay, and I put 100 ohms in there. If you make the resistor too big, it will not be able to supply very much current, and if you start drawing a lot of current on this guy, it will droop. If you make the resistor too small, it will overpower the Zener diode and destroy it. So according to my calculations, 100 ohms was good size for this resistor. So let's try this on our circuit to see how it behaves. See if it behaves better now. Okay. Okay, so here is our circuit and our Zener diode regulator, and let's try, see if I can hold 3 things at once. Okay, so our voltage is going to be across the Zener diode, and this side is the negative side. Okay, and this side here is the positive side. Okay. So it looks like our power supply is working pretty well. We can tune the frequency up and down. Okay, we got good frequency range. So I think our circuit's going to work pretty well. So let's wire this thing up and see if we can hook up the other part of the power supply. Okay, so here is our makeshift regulator that we made up with the Zener diode, 6.6 volts, and a 100 ohm resistor, and I'm attempting to solder it onto our 11.5 volt power supply, which is too high of a voltage. I did not realize that. Should have looked at the specs more closely for our oscillator circuit. Okay, so I just twisted these wires together to keep them in place, and there we go. It looks like it's all soldered up, and I'm going to try to solder it onto the circuit next. Okay. Okay, just want to test one more time. I got the circuit hooked up to our regulator power supply here, and I'll just plug it in. Okay, so it looks like this is correct. So I'm going to remove the red clip lead and solder this thing onto there. I'll just leave the yellow clip lead there as a reminder that that's where we're getting our other power for our other power supply for the amplifier part. And we're going to switch that over to be a variable power supply in a little bit. I like to twist these wires around. That makes a better contact. So there's the red one, and I'll remove the black one now and solder that one on as well, and make this a permanent power supply for this circuit here. Okay, let me plug it in one more time. Should still work. Okay, and here's our solder. So we'll solder this guy up here. This soldering iron is getting a little bit carboned up. You can take like a damp paper towel or a damp sponge or something and wipe it, and that will clean it down. I don't have one of those handy right now. Okay, so there. Well, let's get a little bit more solder on there. Get a good solder joint. I'll hold this wire on. You don't want it to come apart while you're trying to use it, right? Test it one more time. Okay, there we go. So it looks like our circuit is now got a permanent, a steady state power supply for the oscillator chip up here, the phase lock loop chip. And now I'm going to see this lead here, the yellow lead, feeds our load. I don't know if you can see that over there. It goes into the speaker line and feeds our load, and then it comes back and returns here, and so this is where the return of the FET comes to. And so we're going to hook up a new power supply. Between that, we want to share a common ground, probably the black side, when we run that power supply. Okay. Okay, so here's the end of our variable power supply. And like I said before, there's two choices. Either you can put a plug and plug this into it, or we can just chop it off and permanently solder this to what we're going to use. I think I'll just chop it off. And it looks like it's, well, we'll have to strip it back and see what's inside of there, but we got to separate the two different wires, positive and the negative, and strip them back. So let's do that. Take a razor blade, where my razor blade went, and we'll just circumcise this guy. See what's inside here. Okay, looks like a red wire and a black wire. And again, this is our Chinese variable power supply thing here, which I'll be hooking up in a second. And so I guess I'll strip these two wires back and check to make sure red is positive and black is negative. Can't assume too much. If you reverse the circuit, reverse the power in your circuit, you'll destroy it. So let me work on that. We have to, yeah. Okay. There we go. There's red. You do black the same way. Be careful not to cut yourself with the razor. Okay. There's red and black stripped back. Okay. Okay, so we have our variable power supply on. We have red to red and black to black, and it looks like the voltmeter is reading positive, so red is positive. So we'll hook the negative up to the same negative as the oscillator power supply, because we want a common ground there. And we'll hook the positive up to this lead that goes through the load, through our speaker, and then returns back to the FET to a common ground. So the positive will be hooked to that, and then we'll be able to adjust the volume by turning this knob on this power supply. Okay. Okay, so here I just use a clip lead to clip the negative of our variable power supply to the same negative as our constant power supply. So they're all both connected here. Remember, on the other side of the Zener diode, because we don't want to connect on there's a voltage drop here. This is actually our power, the voltage that we want here across the Zener diode. And so I'm connecting both power supplies to that common ground there. And then I hooked up our load wire to the positive point. And let's just turn this guy on. I got it plugged in. And it makes an annoying noise. And here we go. We got our variable power supply here. We can make it louder or softer by turning up the power. And that's just driving more power through the FET. Okay? Let's turn that off. It's getting annoying. So anyway, looks like we're going to have a high power variable signal generator for doing all sorts of really nifty experiments very soon. A very cheap generator that we can plug in a single outlet and carry around. Okay. Okay, so anyway, here's our regulator and a bunch of bare wires here, and what I'm going to do is I'm going to tape these up because you don't want these things to short out to something. And I'll try cutting off some tape. Again, if you use razor blades, be careful, don't cut yourself. I just use whatever's laying around because I got so many things to get done. Just try to do things as quickly as possible. Okay, so there's our resistor and Zener diode. Let me fold some of this circuitry in so I don't have to wrap so much junk. And maybe I'll come around the back side and wrap it around like that to make sure it doesn't touch each other internally as well. I'll just wrap all this up, and maybe we'll find a nice box to stick this in so we can have a nice portable power supply to do some interesting experiments with. Okay. Here's some more leads. I'm going to cut some more tape and wrap them up, get them all insulated. Okay. Definitely don't want these to touch together, so I'm going to wrap the black one independently of the red one, and then I'll try wrapping the red one. Maybe I'll just leave that clip lead on there, make it a permanent part of this so I can clip experiments onto it. Okay, it's looking pretty good. And here's our variable part, and I'll try to put all this together in a box, and we'll see how that goes. Okay, so here's our final product, our power supply, and I took a little plastic case and mounted it over top of my other power supplies and made them look really nice. I taped them together with some electrical tape, and here's I have this switch hooked up to a capacitor that changes the frequency range. You can change the frequency range based on how big of a capacitor you have in there, and the phase lock loop. And here is the resistor that connects to the phase lock loop that generates the frequencies. And let's see, I got it plugged in. We'll just flip her on here. Okay. Look at that. So it's a variable power supply. I can change the frequency. And I can change the amplitude. Make it really loud and annoying. I don't want to blow the speaker out. I'm not going to flip the range because the other range, let me turn this off. The other range goes up very high to drive Tesla coils. And so whether you want to drive high power speakers or coils or ignition coils like what we have over on this guy over here, the nice high voltage ignition coils, you could probably drive one of those with our little driver here, or Tesla coils, or what other experiments you want. And you want a variable voltage and variable frequency at high power, and this generator might be the generator for you. Let's look at that. Beautiful, huh? Anyway, this is Dr. Janes, and thanks for watching.